Hi guys, today is the third day and I've already solved this question, but I'm going to do it again just to reinforce it. So that question is I have two array of numbers, and they are ascending order. They are already sorted, and we have two integers. One is the length of the first array, but it's actually longer. It has like extra zeros based on how many the number of the n. So the length of the first array is m plus n, but the m part is zeros, and the second array is has the length of n. So they are already sorted. What we're gonna do is just merge them together. Because I already know merge sort, I thought it would be easy, but I think this question expects you to do things a little bit differently, because when I was doing merge sort, firstly you need to run you need to divide it first, right? And then you merge them together. This part is just merge them together and merge like two sorted array together basically. But it doesn't work like this. Usually we create a new array and we compare. We have 2 pointers, 1 point here, 1 point here, and we compare and push the smaller one inside of the array. And once we finished any one of them, and then we can add the remaining part in. So I know how to do that, but this one is slightly different. But the first thing that comes to my mind wasn't just using a merge sort kind of style, just merge them together, because it says like we don't need to return anything, we just modify this. Then the first thing comes to my mind is I can merge those together and then use the JavaScript sort method, so it'll be really quick. So the first thing I did is numbers 1, and I splice it and start from the m. So start from here, and I just get rid of that and add that in. So I get rid of n is the number of zeros. Get rid of all this. Then I add the second array in. So I spread the numbers to that. So we already modify this, and we'll return a value of the one has been sliced. So it's gonna be this. So we want to modify the numbers again instead of just like chain it there. So we say numbers 1 dot sort, and it takes cop function a minus b. So it'll be ascending order, and that's it. Sort, sorry, a and b, run. That's a quick one, but it's easy and quick, but it's not ideal because this one is sometimes I'm not so sure how they implement the JavaScript sort algorithm, but I think it uses quick sort sometimes. It depends on like how long the array is. So pretty sure the time complexity, any sort algorithm, the lowest time complexity gonna be log n and log n, sorry. And here they want you to make it like this. So the splice gonna take like m plus n, so this one is not ideal in terms of like being efficient. But like if we want to make the time complexity low, so in the end we still need to use like the 2 pointers way. And in this case, because we cannot make a new array, we have to modify this, and we cannot modify from the start, we want to modify from the end, because the end are a bunch of zeros. So we need three pointers. The first one here actually, from here go back to the start, and the second pointer from here to that, and we compare this one to that one, and I add the bigger one here, and we because this one is bigger, then we compare this one and this one, then the 5 is bigger again, we put 5 here, and we compare this one and this one. 3 is bigger, we put 3 here, and compare this one the same, then we put this one there, and so on and so forth. So that's my idea. So we make 3 pointers, and that's an edge case as well here, saying if the first, if m is equal to 0, then what we're gonna do is we just modify the first number, and that's it. So we just say return, if if m is equal to 0, then we just modify nums1 dot, we just add the nums2 in, and we don't do anything else. So splice actually I don't know, splice from, I think I can do like this, right? Start from 0 and slice 0 should be working. Then it's gonna be modified to this. Actually, we need to splice the first one. So start from 0, splice the first one, and add the whole second array in. Yeah, that makes sense. And we probably don't need this one as well. And then we create 3 pointers. The first pointer is called current1. Is equal to, current1 is equal to m, right? Because we start from here, so it's m. Actually, m minus 1, because const, actually let, we cannot say const for pointers, let, and current2 is equal to m minus 1, and we need 1 from here. So sorted index, let's call it sorted index, is equal to m plus n. So it's gonna be 6, but we only have 5, so minus 1. Right. So we say while, as long as this current ones it's equal is bigger or equal to 0. So current 1 is bigger or equal to 0. At the same time, the second one, current 2, should be bigger or equal to 0. Then we compare the first and the second one. So current, so nums1, nums1, current 1, it's bigger than nums2, current 2. Then what we're gonna do, we compare that, and if the second one is bigger, then we put the second one at the end of the first array. So we say sorted index is gonna +1 anyway, but current one in that case is gonna be, let's say, current sorted index is equal to nums1. Sorted index is gonna be equal to nums, the bigger one, so nums2, current 2, and nums current 2 minus minus. Otherwise, we say it's gonna be pretty much the same, but nums1 dot sorted arrays is equal to nums1 plus nums1 current 1. Okay, nums1 current 1 and current 1 minus minus. And sometimes we, let's say, sometimes everything, so it's gonna be 6, 5, So it could be that we put, those are really big, and we put those big ones here, and this one is no longer 0, but a lot of these are left and haven't added this in, or we add all those in. If we add all those in, that'll be fine. The only problem is we add all of those in, but there's still a few of that left. So there are still like a few zeros there. So what we're gonna do is, let's say, while after this loop, and we still have current 2 is bigger or equals to 0. Then what we're gonna do, we're gonna put them so what we're gonna do is there are like a few things not updated, but we want to add that in. So we're gonna we're gonna replace it with all the remaining current. So we say we do this, right? sorted index minus minus, right? Because here sorted index minus minus should work like this. Please work. Yes. So yeah, that's the solution. I think that one is a lot faster. Let's think about the time complexity here. Sorted array has been run that much times, so basically it's m plus n, so it's a lot faster than the first solution. That's pretty much it. I've already done the test, so this time everything's like there's no stuck in between. I think it makes more sense for me to do it like this, so I'll do the challenge first and then I just make a video about it to make myself remember it better. That's it, guys. See ya.